us look at another example. Let us have a function y is equal to x squared. And we want to find y dashed. Find the derivative of that function. Again, using first principles, let us go to use the definition. Y dashed is defined as the limit as h approaches 0 of the function f of x plus h minus f of x divided by h. Now, in this particular example, our f of x, the f of x is simply equal to x squared. That's what we have in this. And therefore go and feed it into the definition. Therefore y dashed is equal to the limit as h approaches 0. Now f of x plus h is simply going to be x plus h squared, because that is what f does. F actually squares the variable which is inside. And the variable there, it is x plus h, so it squares it. And then minus f of x, which is minus x squared, divided by h. We expand what we have there and get the limit as h approaches 0. Now, if you expand this expression, we get x squared plus 2h x plus h squared. That is the expansion of this one, minus x squared divided by h. That's what we have. And we can continue that therefore y dashed is equal to the limit as h approaches 0 of what we have. The x squared would cancel with this x squared, so remain only with the 2hx plus h squared divided by h. Now, we recall that actually we said h is not 0, but it's something which is getting smaller and smaller towards 0. And therefore, when it is not 0, I'm allowed to divide by it, and therefore I could cancel with 1 over the h there and find is equal to the limit as h approaches 0 of now what I have. The h goes there 2x times, and the h goes there h times. Now we note that as the value of h gets smaller, this one is completely independent of the h, does not change. But as h gets smaller, that is going to get smaller. As h approaches 0, this one approaches 0, and therefore 2x plus h will be approaching 2x. So we find that the limit is equal to 2x. And therefore this implies that if y is equal to x squared, then the y dashed is equal to 2x. So we have been able to find the derivative of x squared using the definition of the derivative